This is Advanced Math, Unit 6, Morning Review. I'd like to first start off fixing number 12. There is a typo. Fixing number 12. Right here, find cosine 2 theta. I edited number 12 and forgot to fix the question. It should ask find cosine of alpha plus beta. There's not even a theta in the problem for me to ask you to find cosine 2 theta. So please fix it. It should be find cosine of alpha plus beta. Got it? And would somebody in the back close the door, please? Thank you. All right, go ahead and flip it back over to the front page. First one, looking at your formula sheet, you can first tell that it is a tangent formula. And because you see the tangent 40 plus tangent 10, you can tell it's this one here. Whenever you're working with tangent, you check to see if it's flipped on the fraction. Because if it's flipped on the fraction, it becomes cotangent. Is this one flipped on the fraction? Thumbs up or thumbs down? Okay, it's not flipped on the fraction. All right, with any of our formulas that has a subtraction sign, which this one does, you check to see if it's flipped on the negative sign. Is this one flipped on the negative sign? Thumbs up or thumbs down? Okay, it is. If it is, that means positive tangent to theta becomes what? Negative tangent, and not to theta in this case, I apologize, of angle A plus angle B, plus because that's between the two tangents. So 40 plus 10, which becomes negative tangent of 50, is 50 degrees one of my special angles on the unit circle? No. So this is our final answer. Questions on number 1? Okay, number 2. Please be careful on the test because you're going to have a lot, like the whole first page, nothing but these type of problems, like a good first 10 to 15 questions. And you're going to be going pretty fast, like, okay, I'm trying to finish this test on a non-block day. And you see sine squared plus 1 and you think of this. But the 2 is missing, and if you're going too fast, you don't see that. So please be careful and pay attention. If the 2 is missing, does it make a difference? Yes, but if you're going too fast, you're not going to recognize the 2 is missing, so pay attention. If the 2 is missing, it's not this formula at all. It's this one over here. And you're most likely not going to have, you most likely don't have your rearrange written, so I'm going to go here. Sine squared plus cosine squared equals 1. And that's what I'm going to write down. Sine squared x plus cosine squared x equals 1. I'll put the 15 in after. Can you guys rearrange in your head? Sine squared minus 1. And if you don't like it in your head, then put it on your paper space. Minus the 1 minus the cosine squared. Bless you. It is a double rearrange. Minus the 1 this way, minus the cosine squared that way. Is it positive cosine squared or negative cosine squared? Negative cosine squared of 15 degrees. No double angle involved at all. Any questions on number 2? All right, number 3 is one of my double angle formulas, but I don't have anything with a 4 or an 8. A volunteer, raise your hand and tell the class what we'd have to do first. Lucas? Factor. Those of you that raised your hand as well, do you guys agree? Okay, GCF. 1 minus 2 sine squared 15. Is that one of my double angles? Now this one does have the 2, so yes. 1 minus 2 sine squared. It's cosine of 2 theta. So 4 times cosine of double the 15. What's double 15? 30. And is 30 degrees a special angle? So would you get it wrong if you left that as your answer on the test? Yes, you would. And if there's a lot of these in the test, that's a lot of points you're going to be missing out on. Go to your unit circle or your brain space, because some of you probably already have it in your brain space. What is cosine of 30? Root 3 over 2. Sometimes kids put cosine root 3 over 2. It's not. It's just root 3 over 2. Bless you. Multiply or cross reduce. I'm just going to cross reduce. 2 becomes 1. 4 becomes 2. What's my final answer? 2 root 3. Questions? All right. Next one we've done a few of. We've done them in notes. We've done them on the practice test. It was on the quiz, which we are getting back at the end of class. Right here, sine of 255. This is the one where we do break it up. You can use 45 or any form of 45. I like to use 45. Subtract 255 minus 45. Can anybody do that in their head? 210. Some kids use different numbers and they do like a bigger number, minus 45, which you can. Our answers will look different, but they'll be the same, and you'll still receive full credit. Okay, do I distribute the sign or use my angle addition formulas and expand it out? Distribute or expand? Expand. Sine of 45, it's friendly, so cosine of 210. And it keeps its sign, so plus sine of 210, bless you, cosine of 45. And then this is where you use your unit circle to evaluate all of those. Go ahead and do that now. All right, what is sine of 45? 1 over root 2. Do any of you write it as root 2 over 2? And it's okay if you do. That's perfectly fine. Cosine of 210 is negative root 2 over root 3 over 2. Sine of 210 is negative 1/2. And cosine of 45 is 1 over root 2. All right, so I get negative root 3 over 2 root 2 minus 1 over 2 root 2. Yes? All right, so negative root 3 minus 1 over 2 root 2. Now, did anybody write it as root 2 over 2 and wants to see what that answer looks like? No? Okay. Again, if you do it that way, that's fine. When I'm grading, I have multiple answers, so you will not get it wrong. Okay. Questions before I move on? Alrighty. Number 5. You need to know on the test when to expand, like we did with the sine 45 plus 210, or when to condense, like we will with number 5. Number 5 has already been expanded. We need to condense it down to a single function. You need to know and recognize when to condense it to a sine or condense it to a cosine. Sine, cosine, sine, cosine. Is that the sine formula or the cosine formula? What is it? Cosine? Sine, why is it sine? Because it has sine and cosine. Do you agree? Sine is the friendly one. If it has sine and cosine, it's sine. Do you guys agree? Okay. I will show you right now. Sine with cosine is the friendly formula. So it is sine of, and it's minus. So we have to keep track of which one's A and B. Is it 20 5 minus 70 or 70 minus 25? The A is with the sign. The A is with the first sign. 25 minus 70, which is sign of negative. I'll give you guys a second to do that in your head. Negative what? 45. Different ways of doing that. You can pop the negative out to the front because that's what sine does with the negative from last unit. Cosine absorbs, sine pops it out to the front. Or remember that sine of a negative angle means you go in the downward direction. My other classes said they liked it better that way, going negative direction. So I'll do that. Positive 45 goes that way, negative 45 goes that way. Do you guys agree? So negative 45 is here. What is sine of negative 45? Negative 1 over root 2. Any questions on number 5? Okay, a really quick side note about sine or cosine of a negative angle. Cosine of negative 30 degrees versus negative cosine of 30 degrees. I had a few kids on the quiz yesterday who treated these two things as the same thing, and they're not the same thing. This is cosine of negative 30, what we just talked about, going in the negative direction. You go negative 30 degrees, and what's cosine of negative 30? What's cosine? Root 3 over 2. Now, I had some kids that treated this the same way. They said, oh, negative cosine 30, that means I'm going in the negative direction. Because that negative is not on the angle, does that mean I'm going in the negative direction? No. This means you evaluate cosine of positive 30 and then take its opposite. So what's cosine of positive 30? And then its opposite would be negative root 3 over 2. Do you see the difference between those two? Okay. Cosine of a negative angle versus the opposite of cosine of a positive angle. Do you understand the difference? Okay, questions? All right. Number 6, back to the tangent functions. This one is the tangent squared, so it's this one here. Is it flipped on the fraction or the negative sign or both? Let's address the fraction first. Is it flipped on the fraction? Yes, so is it tangent, negative tangent, or cotangent? Okay, is it also flipped on the negative sign? 1 minus tangent squared, 1 minus tangent squared. Okay, so it's just cotangent of double the angle. Cotangent of 2 times 40, so cotangent of what? Is that one of my special formulas or special angles? No, that's my answer. All right. Next one, sine of pi over 2 plus theta. We've done this in notes. We've done this on the quiz. I don't remember if it was on the quiz, but it was on the practice test. Where you expand, you never distribute. Sine of pi over 2 times sine, not sine, but cosine of theta plus sine of theta cosine of pi over 2. Kyra, can you tell us what to do next? Do you remember what to do next? Good. We evaluate sine of pi over 2 as well as cosine of pi over 2. Good job. So you guys would do that now. Go to your unit circle. Pi over 2 is 90. Find what sine of pi over 2 is and what cosine of pi over 2 is. They're usually like 1 or -1 or 0. So find out what both of those are. All right, what's sine of pi over 2? And cosine pi over 2? All right, so 1 times cosine theta is going to be cosine theta. And sine of theta times 0 is 0, so my final answer is just cosine theta. Kids will ask, well, what's cosine theta? That's it, that's your answer. We had answers like that in our last test. Cosine squared theta, or just sine theta, or secant squared, or cosecant, and that's fine. Those are answers. It's just like x, or x squared, or y. They're just answers. Any questions? All right, next one. I'm hoping you can recognize that those are not like terms. I cannot combine them. There's not even a GCF. Sine 2x and sine x. There's not a GCF. But I can change the sine 2x. Can you guys see that? And sine 2x, there's only one choice. 2 sine x cosine x minus sine x stays the same. Equals 0, stays the same. Is there anything we can do now? Are there like terms now? Can I add, combine, add or subtract like terms? No, but I can do what? GCF. What is my GCF? 2 leaves me with 2 cosine x minus 1. And I only GCF and factor because it equals 0. And I can use my zero product property. Cosine x equals 1/2, sine x equals 0. There's going to be a total of 4 answers, 2 for sine x equals 0, 2 for cosine x equals 1/2. Now, I would appreciate it on the test. Can I have everybody listen? I know some of you, because you, and yes, typically you should write your angles in order, but it makes it easier for me when I'm grading if you group them, like these 2 answers together and then these 2 answers together, all in a line, like all in one big order space, but these 2 together rather than in order. It just makes it easier for me when I grade. For example, what did you get for these 2? 0, 180, comma, what did you get for these 2? 60 and... So they all look like one set of answers, which is how I want them, but these 2 are next to each other and these 2 are next, rather than 0, 60, 180, 300. Do you get what I'm saying? Okay, it helps me when I'm grading to have them that way. So can you guys please group them together that way when you're taking the test on Monday? Yes? Okay, thank you. All right, next one. Which one are we going to change? Fiona, you okay? Look at your cosine 2x formulas. Which one should I use? Oh, first, second, or third? Second, because there's sine in there. Okay, so 1 minus 2 sine squared. Plus 3 sine x. All right. Are these 2 now like terms, the sine squared and the sine? No, because this is a sine squared, this does not, so I'm not combining. Are these 2 like terms, the 1 and the 2? Should I move the 1 to the right side or the 2 to the left side? the 2 to the left side so it can equal 0, so I can factor and solve. Minus the 2, and let's put things in order. Negative 2 sine squared x plus 3 sine x minus 1. All right, you're taking the test, you get to this problem. What do you do next? Anyone? Yes. Divide by negative 1. A lot of kids factor out the negative 1. The only time you would be forced to factor the negative 1 if there was no equal sign. But if there's an equal sign, just get rid of it. Yes, you could divide it out, but why if you can get rid of it? Often kids I've had it this year, a lot of kids factor it out, and then at the end they ask me, what do I do with it? Nothing. That's why I tell you to just get rid of it, because at the end it messes kids up. Okay. Anybody know what to do next? Subtract? I don't want to subtract. I want to leave it there. Double bubble? Use, what was that? Good. Double bubble and or use substitution. Okay, so if you want to double bubble it as it is, factor, is that okay? Yes. If you want to use substitution first and then double bubble, is that okay? Yes. I'm going to use substitution because I usually do with you guys. U equals sine of x, not sine squared. So I get 2u squared, not 2u squared and then x, minus 3u plus 1. Double bubble. What's nice about 2u squared is the only factors for 2u squared is 2u and 1u. 2u and 1u. Go ahead and do that now. Continue factoring. The only factors for 1 are 1 and 1. And because it's positive, the two signs are the same, and the neighbor tells me they're both negative. So really there's no guessing. There's checking. Check it right now to see if it works. Inside, outside, do you get negative 3 in the middle? So set equal to 0, you get u equals 1/2. U equals 1. Sine x equals 1/2. Sine x equals 1. And you solve. Group your answers together. What do you get for sine x equals 1/2? 30 and what? Anyone else get that? 30 and 150? Put those two together, and then what do you get for sine x equals 1? All right, questions before we move on to the next page? No questions? Yes. Did I skip number 10? I did. Thank you. Number 10. Number 10 is actually one from the quiz, which again we will be getting back in just a little bit. Only thing is on the quiz it wasn't as a proof, but here I put it as a proof. What side are we going to pick? Left side. And what was the hint? I gave you guys a hint on the quiz. What did I tell you to do with it? Difference of two squares. Sine squared theta plus cosine squared theta times what? Good. He said sine squared theta minus cosine squared theta. And then you guys should have looked at it and said, oh, this here, it wasn't on the board, but it was in your head. What is it? 1 times this one. Oh, it was on the board at the time. Now it's in your notes. What is sine squared minus cosine squared? Negative what? Negative cosine 2 theta. What's 1 times negative cosine 2 theta? And is that what we're trying to verify? Any questions? Make sense? Okay, flipping over to the other side. All right, number 11. 11A is a little tricky because you see the two thetas and you're all caught up and ready to like use formulas, but it's not. And here's why. Like first off, have we seen any formulas with tangents and sines and cosines together? No. So you're going to use some basic old last unit, actually old unit stuff. What is tangent as far as sine and cosine? So change it to sine 2 theta over cosine 2 theta. And cosine, there's nothing to change it to. Leave it as cosine 2 theta. So we're using that old trick of change everything to sine and cosine. That was our tricks to try that we had. Was that last unit stuff? Okay, does it reduce? And what are we left with? And is that what, look at the other side. Is that what that equals? So is this true or false? Any questions? All right, next one. Tricky. Ignore the 2's completely. Act like the 2's are not there. Would you guys all agree that cosecant squared does equal 1 over sine? Yes? Okay, so ignoring the 2's, cosecant squared does equal 1 over sine. Now, when I change cosecant squared to 1 over sine, and this, we did have one of these on, it was the notes or during, no, it was during the practice test. When I change something to a fraction, does the 2 move with it to the denominator or stay in the numerator? Stays in the numerator, so this is a false. What this should, the way this should be written as is 2 over sine theta. That's the way it should be written. The 2 should stay in the numerator and the sine move to the denominator, or 2 times 1 over sine. Either one, 2 over sine or 2 times 1 over sine. Make sense? All right. 2 sine theta cosine theta over 1 plus, and cosine 2x is what I'm going to change. I also changed sine 2x. I didn't say it, I just changed it. And I'm going to change those thetas to x's. Okay, do you guys agree? Now, here's the deal. Do I have 3 choices for the cosine 2x? Yes? Here's the one that I picked, and I'm going to explain why. And there's really no reason other than what I'm going to tell you right now. Are you ready? I didn't pick the first one because I didn't want to use anything with sine squared and cosine squared, and rarely do we ever pick the first one, right? Like we never ever really pick it. I picked this one only because what did I want to happen to the ones? That's the only reason I picked it, because I wanted the ones to cancel out, which leaves me with 2 sine x cosine x over 2 cosine squared x, would then allow me to what? Reduce not only the 2's, but what else? One of the cosines, cosine at the top is gone, and cosine squared becomes, and I'm left with sine over cosine, which is tangent x, and is that what we have on the other side? So true or false? Any questions? Yes or no? All right. Oh, I'm going to stop here, and I will record myself finishing these last 3 because you will have to finish these last 3 to turn in as well. Any questions?